Let's solve some more integrals. First one, integral of 1 plus tan x to the power of 7 times sec square x dx. Now here, what would be the substitution? We know that the derivative of tan x is sec square x. But what if we differentiate 1 plus tan x? 1 will disappear. So that means we can do the substitution u is equal to 1 plus tan x. So when we differentiate it, we get du is equal to sec square x dx. So after substitution, it becomes integral of u to the power of 7 du. And we know that the integral u to the power of 7 du is equal to u to the power of 8 by 8 plus c. So let's bring back x. So which is equal to 1 plus tan of x to the power of 8 divided by 8 plus c. Okay, let's look at the next one. Now again here, what would be the substitution? Now, if you can visualize this, we can look at it as 1 by x times natural log of x dx. We know that the derivative of natural log of x is 1 by x. So which means we can say u is equal to natural of log of x, which means du is equal to 1 by x dx. So after substitution, we get integral u du, which is equal to u square by 2 plus c. And substituting back u, we get natural log square of x by 2 plus c. Okay, let's look at the third one. Integral of dx by 1 plus e to the power of x times 1 plus e to the power of minus x. So let's do a little bit of algebra first. Let's take e to the power of minus x to denominator. Then let's add up these two terms in this factor. We get e to the power of x plus 1 by e to the power of x. Now here, 1 plus e to the power of x and e to the power of x plus 1 are the same. So we can write this as integral of e to the power of x dx divided by 1 plus e to the power of x square. Now how did this come in the numerator? Because in the denominator of the denominator, we have e to the power of x. So that goes up. And now we can do the substitution. U is equal to 1 plus e to the power of x. So du will be e to the power of x dx. After substitution, it becomes integral du by u square, which is equal to u to the power of minus 2 times du. And that is equal to minus u to the power of minus 1 plus c. Or we can say minus 1 by u plus c. And substituting the value of u, we get minus 1 by 1 plus e to the power of x plus c. Okay. Fourth one, integral 4x square dx by 1 minus 8x cube the whole to the power of 4. So here we substitute u equal to 1 minus 8x cube. So du will be minus 24x square dx. And which means 4x square dx is equal to minus du by 6. Why specifically 4x square dx? Because that is what we have in the numerator. So now the integral 4x square by 1 minus 8x cube to the power of 4 dx becomes minus 1 by 6 integral u to the power of minus 4 du. And we know that if we integrate u to the power of minus 4 du, we get u to the power of minus 3 by 18 after simplification. Again, resubstituting u with what we had assigned, we get integral of 4x square by 1 minus 8x cube to the power of 4 dx is equal to 1 minus 8x cube to the power of minus 3 divided by 18 plus c. Or simplifying it further, we get 1 by 18 times 1 minus 8x cube to the power of 3 plus c. Now here what do? We take u is equal to 1 minus cos x. So that du becomes 0 minus sin x dx, which is equal to sin x dx, which is what is there under the integral as well. So our integral sin x times square root of 1 minus cos x dx is equal to integral square root of u du, which is equal to, we can write it in the radical form. So integral u to the power of 1 by 2 du is equal to u to the power of 3 by 2 divided by 3 by 2 plus c, which becomes 2u to the power of 3 by 2 by 3 plus c. So we get 2 by 3 times 1 minus cos x to the power of 3 by 2 plus c. Sixth one. Now we have a definite integral. Integral from 2 to 4 of 1 by x divided by natural log square of x dx. So let's take u is equal to natural log of x. Why? Because we know that the derivative of natural log of x is 1 by x, which is there in the numerator. So du is equal to 1 by x dx, and now that we have this as definite integrals, we have to change the limits as well. So if x equal to 4, u is equal to natural log of 4. And if x equal to 2, then u is equal to natural log of 2. Our original integral becomes integral of du by u square from natural log of 2 to natural log of 4. When we integrate, we get u to the power of minus 1 by minus 1 from natural log of 2 to natural log of 4. Minus up and u to the power of minus 1 down. So we get minus 1 by u from natural log of 2 to natural log of 4. And now we take care of the limits. Minus 1 divided by natural log of 4 minus 1 by natural log of 2, which is equal to minus 1 by natural log of 4 plus 1 by natural log of 2. Now we add these two. So LCM will be natural log of 4 times natural log of 2. In the numerator, we'll end up with minus 1 times natural log of 2 plus natural log of 4. We just, rearrange this so that we get a positive sign in the beginning. Natural log of 4 can be written as natural log of 2 square minus natural log of 2 divided by, again, natural log of 4 can be written as natural log 2 square times natural log 2. Now, in the numerator, we can write this as 2 natural log of 2 minus natural log 2 divided by 2 natural log 2 times natural log of 2. Now, here you have 2, here we have 1. So, 2 minus 1, 1 natural log 2 divided by 2 natural log 2 times natural log of 2. So, natural log 2 cancels, and we are left with 1 by 2 times natural log of 2, which is equal to, because 2 can be taken up as a power, so we end up with 1 by natural log of 4. Finally, we can write it integral from 2 to 4 of 1 by x divided by natural log square x dx is equal to 1 by natural log of 4. Let's take the seventh one. Integral of e to the power of 1 by x divided by x square dx. So here, what do? Again, we take u is equal to 1 by x. Du will be minus 1 by x square dx, which implies minus du is equal to 1 by x square dx, which is what we have, 1 by x square dx. Okay, so after substitution, this minus sign, we can take it out. Integral e to the power of u du, which is equal to minus e to the power of u plus c. So our integral becomes minus e to the power of 1 by x plus c. So be careful, whether it is a integral or whether it is a definite integral. Eighth one, integral from 1 to e of 4 to the power of natural log of x divided by x dx. So again we have 1 by x. So u is equal to natural log of x. Du is equal to 1 by x dx. Again it's a definite integral. So x equal to 1 means u is equal to natural log of 1, which is equal to 0. And x equal to e means u is equal to natural log of e. They are inverses of each other, so they both cancel out and 1 is left. So after substitution, our integral becomes integral from 0 to 1 of 4 to the power of u du. And integral from 0 to 1 of 4 to the power of u du is equal to 4 to the power of u by natural log of 4 from 0 to 1. And now we take care of the definite part of the definite integral. 4 to the power of 1 divided by natural log of 4 minus 4 to the power of 0 divided by natural log of 4. So 4 minus 1 divided by natural log of 4, which is equal to 3 divided by natural log of 4. Again, this can be written as 3 divided by 2 natural log of 2. Okay, ninth one. Integral from 1 to 2 of cos of natural log of x divided by x dx. Again, we have 1 by x. So, which means again u is equal to natural log of x. Du is equal to 1 by x dx. And since it is a definite integral, when x equal to 1, u is equal to natural log of 1, which is equal to 0. And when x equal to 2, u is equal to natural log of 2. So after substitution, we get integral from 0 to natural log of 2 cos u du. And the integral of cos u is sin u from 0 to natural log of 2. Taking care of the limits, we get sine of natural log of 2 minus sine of 0. Sine of 0 is 0. So we are left with sine of natural log of 2. So the integral from 1 to 2 of cos of natural log of x divided by x dx is equal to sine of natural log of 2. But remember, plus c is not required. Why? Because here it would have got cancelled out. So when we are talking of definite integrals, we don't have to add the c. Okay, 10th one. Integral of cot of sine inverse of x divided by square root of 1 minus x square dx. Now here we take u is equal to sine inverse of x, which means x is equal to sine u. Differentiating it with respect to u, we get dx by du is equal to cos u. We had dx by du. Let's take the reciprocal. We get du by dx is equal to 1 by cos u, which is equal to 1 by square root of 1 minus sine square u. Nothing great. This cos u, we have written it in terms of sine. So du is equal to 1 by square root of 1 minus x square dx, because sine square u, sine u is x, so sine square u is x square. So our integral cot of sine inverse of x divided by square root of 1 minus x square dx becomes integral of cot u du. Just check out the substitutions. And we know the integral of cot u is natural log of sine u plus c. Don't forget the absolute sign. So our result is integral from cot of sine inverse of x divided by square root of 1 minus x square dx is equal to natural log of absolute value of sine inverse of x plus c. But here sine and sine inverse are there. So which means we are left with x. So final result is natural log of absolute value of x plus c. So we have solved around 10 integrals. We will continue this for, in the next session, starting from 11. A reminder again, there is a link to a PDF book which describes all these in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.